Hi, welcome all. So it has been a long time that we see you physically. So last semester you have your exams, internal exams have been finished. Now you are getting into your final year of your graduation. So this semester I'm going to take the subject called Design of Machine Elements 1. Okay, this is indeed a very important part if you consider for your industrial as well as your applicate engineering life. This subject is going to be very important. So the aptitude questions, the interviews, everything, this paper is very important regarding all these things. So once again, I hope all of you are safe. Okay, now we'll start the basics of this design of machine elements subject. So before that, what is a design? What do you mean by a design? You have already done with your design engineering as well as design project, all these things you have done already. So you might be knowing what is exactly how you an engineer, how should he design something. So the initial step is that you need to find out the problem, right? So there should be some problem or there should be some need of the hour, right? So the first point for design is a problem definition. What is the problem arriving in the say in a machine, or you can take the overall world. What is the problem that is happening? So pick out that problem and then you need to do some literature survey. We'll call it as literature survey. That means what are all the existing technologies that supports or that is related to that problem. Okay, so what are all the existing developments that have done with this problem, or some properties related to that problem, that is called as literature survey. Then you need to analyze your own to develop a new product. You need to develop a new, it should not be a product, it can be an idea. You need to go on analyzing that problem with the help of these articles or the literature survey that you have done. Okay, so you need to analyze what is going on. How can I improve this? How can I prevent this problem and get a solution for this problem? So you need to analyze and you need to go and do a prototype. You need to share your ideas and then you need to launch that problem in the market or launch that product in the market. So this is the basic design phase of any engineering product or engineering concepts. But here we are going to analyze the design of machine elements. You know that almost all the machine elements, after a lot of working, they undergo some fractures, rupturing, all these sorts of things. It happens, right? So it is very important that which material or what thing you have selected for a particular operation, right? If you are selecting a shaft, you need to know the application. The shaft is undergoing some operation like turning or phasing. So which tool you should use for that, or what sort of application is this shaft made of? So for what application? So all these things you need to know, and you need to analyze what sort of material is suitable for this type of operation. You need to analyze this. So if I am doing a machining operation, what are all the stresses involved in it, what is the strength of that material, hardness of that material, and many mechanical and physical properties of that materials has to be studied. Okay, so for all the machining elements we are going for a design, and this is what this paper is considered about. So basically you need to have a basic prerequisite knowledge on mechanics of solids or strength of materials and basic statics, that means engineering mechanics basics you need to know. Already you have studied mechanics of solids as well as advanced mechanics of solids. All these things you have already studied. The equations and concepts from those papers are being taken, and we'll apply those things in your design of machine elements. Okay, it's not about mugging up many equations or something like that. Of course this is a analytical or problematic paper, but you have a handbook with you. You will be having a handbook with you, design data handbook. I prefer to buy Mahavir Reddy's handbook. I will be referring that one. So please buy a handbook for that. The same thing, Mahavir Reddy, that already I have shared with you. Okay, so in that book you will be having almost all the equations. Okay, you just need to, in the exam itself you just need to refer it and write that equation, that's all. But how will you do? There is a process. It's a design. It's just like a designing process. You need to do it step by step. What all equations at what all times, what are the concepts that has to be applied. All these things you should know. So if I just tell you about the syllabus part, module 1 is almost 70% or more than that. It's mainly theoretical part. Okay, the first, what is a design process, that you have already learned. Even though I will tell you the major steps, or I will share you the PDF regarding the design process, what all things you should consider when you undergo a design, and you need to know about the material properties, elasticity, plasticity, ductile, brittle, strength, all these things. Okay, you need to know all these material properties, combined loading and stress concentration factor. There are many types of loading like axial loading, bending moment, as well as torsional loading. All these things, if you combine all these loadings in one machine itself, what happens? And if what is the stress concentration factor, which mainly depends on the geometry of a machine, how it changes. Okay, all these things we will discuss in first module. The second module is another major thing is theories of failure. How a material can get failed. Okay, so there are some theories regarding that. In what all conditions a material can fail. So there are some basic equations regarding that. Here also the second part is about shock, impact, loadings, all these things, the factor of safety, endurance limit, all such factors comes into the picture, and we need to do some problems regarding all these things. And soon after the first and second module, we will get a base for this subject. Then we will go and analyze each type of machines or each type of materials. Okay, from the next chapter onwards. Module 3 we will be learning about threaded and bolted joints. You will be learning about the stresses in threaded joints, stresses in bolted joints, all these things, and we can do problems regarding that. Principal stresses, what will be the diameter, how we should design a threaded joint, of how much diameter should be designed if the maximum stress that the material can avail is this much. So with those factors you need to find and design a joint, a threaded joint, that can be bolted joints. So these factors will come in third module, and again in fourth module It's about riveted joints, quarter and knuckle joints, and welded joints. The same procedure you need to find out. You'll be knowing the stresses. You need to design how maximum stresses, then how you can design that. Okay. Fifth module is about springs, leaf springs. There are many types of helical springs. All this here also the same thing is happening. You need to find out the stresses arising in different modes of springs, different types of springs, and you need to find out. And the last module is very, very important. The shaft, how you design a shaft, and how you design a coupling. Okay, so these two methods, the same thing. What are the stresses induced in it? How will you find out the length of the shaft, the diameter of the shaft? How can you design based on its stresses involved? Okay, so this is just an overview for your subject. So I will tell you one more detailing in the module 1 that we will start in the next lectures. So module 1 is based on your basic understanding of your prerequisite, that is mechanics of solids. Okay, initially you need to know how a design can be carried out. What is the steps for a design? All these things you will be learning, the steps. And for each and every design, so for particular material there will be some standards and codes. If this is mild steel, for a particular operation you will be favorable to do the operation on mild steel of some code, MS25, MS30, some codes will be there. So on what basis they will make these codes, and how you can analyze these codes, that all we'll see in this first module. And very important, the properties of material. There are mainly physical and mechanical properties which affects the design of a machine element. Okay, physical properties can be color, order, size, something like that. And mechanical properties, there are many mechanical properties: strength, toughness, stiffness. All these things depends on it shows mechanical properties. So all these mechanical material properties has to be known. You should know what are all these mechanical properties. Okay, and elastic and plastic behavior. Again, you're getting back to the basics of mechanics of solids. What are the elastic and plastic behavior of materials? Okay, elasticity and plasticity, the stress strain diagram for ductile and brittle materials, all these things you should recap. Okay, and loading types, the stresses. Actually there are mainly axial loading due to bending moment, I told you, and due to torsion. In axial loading itself, it can be tensile or compressive. There will be shear stresses. All these things we have already learned it. So accordingly we'll be having stresses like that: axial stress, compressive stress, shear stress, all these things. Okay, and the final part for this chapter is stress concentration factor. What do you mean by stress concentration factor? See, actually for a normal material, if you pull this material, the stress will be uniformly distributed, right? The stress distribution will be uniform. But what happens if you are keeping a hole on it? This method you have already studied in your advanced mechanics of solids. So what happens if the same force is applied? What happens? The stress concentration will not be even, because here you don't have a material, the area is reduced. So what happens if the area is reduced? The stresses increase, because stress is forced by area. So if area is reduced, stress should increase, right? So there will be stresses generating towards this hole. Okay, that is known as a stress concentration. So for depending on the geometry, the stress concentration, the maximum stress that happens on this object will be increased. So if the maximum stress is increased, you need to design, or it cannot avail much loads, right? So basically in all these things, in all this design purpose, you have to find out the maximum stress. What are the maximum in which area or which part, or what is the maximum stresses which is happening, right? Then only we can accordingly we can design the machine elements. Okay, so all these things you need to find out the maximum stresses. That is the main point, or yield point. That I will tell you why maximum stress or ultimate stress or yield point, that depends on the materials. Okay, so this type of analysis has to be done in this paper. So hopefully we'll start the lecture in the next class itself. So get back to your academics, start learning these subjects. This semester you will be having it's similar to what you have studied like in S3. Many tough subjects, CFF, DME, all these are problematic, and RAC, all these are problematic subjects. So you should listen all the lectures clearly. I'll produce a good lecture for you. Okay, thank you.